right. Hello again. I don't know if you're watching this video right after the first one. If so, sorry I look different. That's weird. I got a new ring light, and so I can film these like during the nighttime or anytime I don't need sunlight. But I realized that you could see the reflection of my ring light in my glasses the whole time. So took those off for this video. So this lesson is going to be on box plots. So we talked about those a little bit in the last video on quartiles and interquartile range. We're going to use those quartiles to create a box plot. And so this is going to be the second visual display that we've learned about for our data units. We had dot plots or line plots, and now we're going to have box plots. So box plots are also known, so if you have a parent or guardian that's helping you, or an older sibling or something, they might recognize more the name box and whisker plot. And so I'll talk about when we make it where that and whisker name comes from. But box plots, we talked about this last time again, are a visual display that shows a 5-number, too big, summary about how the values in a data set are distributed. Remember, distributed means spread out. So we're going to be looking at just those 5 numbers that we talked about in our last video. Least, greatest, you know what, I bet that's, yep, there we go. Least and the greatest. We're going to have the median. And then we're going to have the lower quartile and the upper quartile. So whereas with a dot plot or a line plot, we needed all the values in our data set, a box plot is only going to use those 5 values. So an example. It's another set of student heights. This is not the same data set from the other lesson, so you cannot skip this step here with me and just use those numbers because these are different. But we've got another set of student heights in inches. So the first step of making a box plot, so now everything we did in the last lesson for this week is going to be kind of combined all into one step here because that's just the first part of the box plot, is to find those 5 needed values. So 45 it looks like. You know what? Let me do my lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Oh, good spacing. Okay, 45. 46, and I see 2 there. Okay, we've got a 47. We've got 3 48, so that would be called the mode. Good. 2 52s, and a 56, and a 57. So even though there's 2 52s and 2 46s, there's 3 48s. So that would be the mode. Just want to point that out there. It's really blurry for some reason. I hope it's not for you guys. Okay, well, is what it is. All right, so our minimum is 45. Our max is 57. That is a cat hair. Okay, we've got our median, so left, right. 48. So since we have one singular value, remember we're not going to include it in our halves of data when we find our lower and our upper quartiles. So left, right. There's going to be our lower quartile, and then left, right, left. There's our upper quartile. So if you are still struggling with what we just did here, Maybe you watched the whole first video and then are straight on this video, but this part doesn't make sense to you yet. You're going to want to go practice that first before you move forward, because if we can't find these 5 values, the rest of this is going to be, more difficult for us. So make sure you feel comfortable finding those 5 values. All right, so step 2, we are going to use a number line to create the box plot. So like a dot plot, we are going to put these on a number line. I feel like I'm really dark. There we go. Oh, that gets bright. Okay, cool. I got that for my birthday. We're going to use a number line to create the box plots. So let me just do that. Make sure you're paying attention to your scale, of course. And then because we're only using the 5 values, even though some of our data is on the number line, doesn't mean we're going to plot it, okay? So when we do the dot plot, or the box plot, the first thing we are going to do, though, is put a dot, that's why I said that, put a dot above those 5 main values. So 45, if we're counting by 2s here, we know that 45 is going to be right between 45 and 46. Don't put it down close to the line. You can't really see that. Don't put it down close to the line. You need to put it up a little bit higher, and you'll see why when we draw the rest of it. So 45, 46, 48, 52. I probably put mine a little too high because it's all kind of cramped, but it's whatever. 57. Okay, so first step or second step of making the box plot, easy peasy, just 5 dots at the numbers that you already found, those 5 main summary values. So the next thing, we are going to draw 3 vertical lines. Remember, vertical is up and down, vertical is the y-axis, y. So vertical lines through the Q1, Q2, Q3, or if you want to say the lower quartile, the median, and the upper quartile. That's super hard to read. But we're going to do those 3 middle values that we talked about last time with that center 50% chunk of our interquartile range. So just like this. And then it says connect the vertical lines to create a box. So this is where the box part of the box plot comes in. Yeah? So this is that 50% of our data, even though clearly this wasn't, like the box itself from the lower quartile to the upper quartile wasn't cut right in half. Clearly we can see that. This is still 50% of the data, and this is 50% of the data, because now we are actually paying attention to the exact values. So we were talking about spread earlier. We can see that this 25% chunk, let me pull that back up. Boop. So this 25% chunk is closer together, not as spread out as this 25% chunk. All right, the last thing we're going to do is draw 2 horizontal. Remember, horizontal is left to right, side to side. We drew the x-axis is horizontal. From the ends of the box to the least and greatest. I should have put maybe minimum and maximum there. And these are what we call the whiskers. Because it kind of looks like they're just poking out from the box, like a cat's whiskers poke out from its face. And so again, this also shows the spread of how far each chunk of the data is. So like this right here is the bottom 25%. This is that middle 25%, 25%, 25%. This is the top 25%. This is that middle 50%. So we can see that maybe the greatest is pretty spread out from the rest of the box, but at the same time, almost like this whole upper 50% of the data is really spread out. So we're talking about student heights here. So these are all pretty close together. So they're kind of not really, and then once they start getting taller, a lot faster is kind of what we could almost infer from this box plot. So again, we're showing the spread of the data, and so that's why I'm paying attention to how far apart or how close the box and the edges of the box and the whiskers are, because that says a lot about how far apart is that data spread. So we're going to keep going with another example. So I jumped ahead on the last section. At this point, you should not be surprised. I am not. Box plots can be used to show the spread. Let's think of what went there. Show the spread of not only the whole data set, but also different percentages, pieces, parts of it. So, like I already got to. Sorry about that. Okay. The daily high temperatures for some days last month are shown. Make a box plot of the data. So there's a lot of room here because we have to do all those steps for this set of data. So the first thing is we're going to need to use this data and put it in order from least to greatest. We've got 1, 2, 3, 1, 2, 3, 4 times 3 is 12 data values. So that should tell you right off the bat we're going to have to find some medians or some means of 2 median values because 12 is even. 10, 11, 12. All right. Let's see. 70s and 80s and 90s. So we'll start with 70s. 78, 78, 79. There's 75 is going to be the least. 78 are 2 of those. So that might be the mode. 79. 80s. We got an 80. And 83. 84. 85. 88. And 89. And then we've got a 92 and a 94. All my values are checked, all my lines are filled, so we're good to go. We need to use this list to find our 5-number summary. So I'm going to go ahead and write some spots here for me to calculate those things, or record, just so I'm not trying to like decipher between which circle around a number is which. You don't have to do it this way. As always, whatever makes sense to you. I just gonna do what makes sense to me, just because this is notation. So minimum is 75, maximum is 94. For our median, left, right. No, I'm gonna do the lines. I did that last video too. Spice it up. 1, 2, 1, 2. There we go. All right. Our 2 middle values are 83 and 84. So if you want, we can add and divide, but I hope you know what number is going to be right in between those 2 numbers. 3 times, which is 6. 7 minus 6 is 1. Remember, we can add a decimal and a 0. Decimal up, 0 down. 5 times. So our median is 83 and a half. For our lower quartiles and upper quartiles, because we had 2 medians, remember we are going to include the lower median value and the upper median value in my 2 data halves. So same thing, left, right, we've got 2 in the middle. 78 and 79 when they're 1 apart. Think about money. It could be 78.5, 78 and 5/10, 78 and a half. Same thing here. Left, right, left, right. 88, 89. So 88.5. Good? All right. So on our number line, it looks like we're counting by 4s. There's lines in between, which means we're counting by 2s. I've got some halves, so my values might be a little bit off. So that's okay. Just make sure you're being as accurate as you can. Half is pretty easy to gauge, but now we're going to be gauging the half of a half since it's counting by 2s. But 75. So if this is 74, that means that's 76. which means that's 75. Don't forget to draw your dots a little higher. Excuse me. 78.5. So that's 78. That's 80. So that's 79. So 78.5 is going to be right here. I don't know if you could have seen my hand was in the way. So that's 78. 82. So that's going to be 80. And then that'll be 79. So if we're doing 78.5, it's going to be right there, kind of a fourth of the way. 83.5. So 82. This is 84, which means this is 83. So 83.5 is going to be right there. 88.5. So if that's 86.90, this is 88. So that's 89. So 88.5. And 94, right on the line. Last one was easy. Cool. So once you have your 5 dots, remember your box is going to go around that middle 50%. So your median, your lower quartile, your upper quartile. Both halves of that box looks pretty equal, so it's interesting. And then we're going to draw our whiskers. So our left whisker is a little shorter than our right whisker. So with a box plot, lots of information you can find out from the data. So the range of temperatures, remember the range is the greatest minus the least. So 94 minus 75. Remember, well, 94 minus 20 would be 74, so one less. So that's going to be 19. So it's a pretty decent spread of temperatures. If we're talking about temperatures, especially outside, 20 degrees. Think about if it's 70 degrees outside, it's pretty nice. 20 degrees less than that, 50. It's a lot colder. So the interquartile range of temperatures. So this is when we're going to do our upper quartile minus our lower quartile. So 88.5 minus 78.5. That's going to be exactly 10. It's a little bit smaller, almost half the range. And so that says a lot about that middle chunk of data only being 10 degrees difference compared to almost 20. So that is because this excludes any outliers, like we talked about earlier when I jumped the gun on sharing that part of this lesson with you guys. So I wouldn't say that there are any outliers in this data set. 75 is pretty close to 78, 79, 94 is definitely not super far away from 92. But that is something to note, that the interquartile range, like we said before, we're not handling that least value and that greatest value, which those are the only values that could be considered an outlier. Something in the middle can't really be an outlier because it's in the middle. So the interquartile range is, like I said, going to be interesting to compare sometimes to the rest of the data, or especially to the range. All right, and then going back to what each kind of whisker in each box represents. So for this one specifically, this is just a couple of things we can pull out, not necessarily everything. So we can say 25% of the temps are below that lower quartile, are below 78.5. A whole quarter are less than that lower quartile, 78.5. We could say 50% of the temps are between our quartiles, our lower quartile and our upper quartile, so between 78.5 and 88.5. We can say 25% of the temps are above that upper quartile, 88.5. So a quarter of our temps are higher than 88.5. And like I said, there's a lot of other different things we could say. We could say 50% of the temps are below, what's our median? 83.5. So half of our data is below 83.5, or half of our data is above 83.5. So a lot that we can pull depending on kind of what part of the data we're looking for. Temps, if we're looking for more of the lows, if we're looking for the highs, if we're talking about test scores again, looking more so, how did the kids who performed really well do, or overall, how did the kids that didn't perform so well do, that kind of thing. Uh, and so then with box plots and with these different things that we can point out, these measures that we can look at, these inferences we can make, box plots are going to be very helpful in comparing two sets of data. So this is the last page of these notes, so we're almost done. But if we've got two sets of data that's representing maybe a similar sample, a similar set, if I go ask a sixth grade math class a question, and then I go ask a sixth grade social studies class the same question, what kind of data would we get from there? Maybe if you asked my first period something, and then you go and ask Miss Alford or Miss Resnick's first period, who also teach sixth grade math, something, what might that data look like? And a box plot would really kind of help show and compare that. Again, going back to when we learned about even dot plots too, opposed to just looking at all the numbers and, trying to figure out what's going on with them. When we put them into this visual display like this, or even if we just find the mean, the median, the mode, the range, it can be a lot more helpful to make inferences on a data set. So, examples. The box plots below show the precipitation for the same city in January and June. Precipitation means rain. So I went ahead and drew these for you guys and did them in a different color so you could kind of point them out. But right off the bat, before I say anything, I hope you're looking at these box plots and kind of noticing some differences already. And we're going to point out the mathematical differences of those, the specifics. But even just by looks, like these whiskers are really long. These whiskers are really short. And that says a lot. Maybe there is an outlier here, right? For the whiskers to be that long, but then the boxes are almost kind of the same size. So that middle 50% of both data sets is the same spread, definitely not the same values, because the greatest one here, so the upper quartile of January, is the same as the lower quartile of June. And so if we're talking about amount of rain, precipitation, then which month are we clearly getting more rain in? June, right? Even though January has this one value that's greater, 50% of June's data, well, actually 75% of June's data is greater than just 25% of January's, because the only thing more than January here, or more than June in January here, is this one whisker, that 1/4 of the data. So again, just looking at it says quite a lot. So I've got a handful of questions here that we're just going to go through. Just again, this isn't everything you can pull out from it, but these are some important pieces I think that can be helpful when we're comparing two box plots this way, two sets of data. So the range of precipitation for January and June. So for range, remember we're talking about the greatest and the least, so we're talking about the ends of those whiskers. So this looks like it's at 2.5, 1.3, so 25 minus 13 is 12, so 2.5 minus 1 and 3/10 is going to be 1 and 2/10. For June, we've got 2.4, I'm going to write it down here, and 1.9. 24 minus 19 is 5, so 2 and 4/10 minus 1 and 9/10 is going to be 5/10. I have some tape there because I drew my box plots on a separate sheet of paper, and that's literally not working at all. 0.5, there we go. Sorry about that. So that says a lot, right? The range here is only 1/2 inch for June, whereas the range for January was over an inch, more than double the range for June. Interquartile range for January. So the interquartile, remember, just looking at the spread of the box. So 2.0 minus 1.5, that's like $2 minus $1.50, you're going to have 50 cents left. Look at that. The interquartile range for January is the same as the entire range for June. 2.3 for the upper quartile for June and 2.0. So 3/10. So the interquartile range for June compared to the range for June is really not that different, right? 2/10 of an inch apart. It's not that much. Whereas the interquartile range for January is less than half the range for January. That right there almost alludes to the fact that there's probably an outlier, or that some of this data, the bottom 25% and the top 25% of the data for January, they're spread apart. They are very distributed, whereas that middle 50% for January is a lot closer together, just because of how these vary, especially because we have June to compare them to. So, in which month was the amount of rain more spread out? We just answered that question, right? Definitely January. Um, which month had the greatest amount? Also January. So January did have the greatest amount of rain on that one particular day, maybe. Which month had the least amount? Also January. So I feel like these two questions kind of, again, prove this point right here. But does that necessarily mean that January had the most rain? No, not at all. It had the most rain at that one time, right? The greatest value is the most. But because it also had the least and because it was more spread out, I'm going to pop down to this question here. In which month might the amount of rain be more predictable? Well, it's going to be June, right? Because the spread is a lot closer together, right? We're in between, what is it? 1.9 and 2. We've got 5/10 of guessing room here. So really not that much. We'd be pretty close if we were to come up with that typical value, right? That 1 or 2.1 right there in the center. Whereas 1.8 is the median here compared to 1.3 and 2.5. So pretty spread out, yeah? All right, so did either month have an abnormal amount or lack of rain? So that's January. It's basically saying, hey, there's an outlier there. Looks like maybe on both ends. So I'm going to put that in. Question mark? Maybe? How many days was the amount of precipitation collected for? So meaning like in this data set, how many days did I have an amount of precipitation for to where I found these 5 values from? From this box plot, we don't know. So that's one of the biggest differences, like I said, from a box plot to a dot plot. I feel like I said that already, that a dot plot or a line plot is going to show you every single value in a data set, and a box plot is not. It's just going to show you those 5. So if you didn't create the box plot yourself, if you're just looking at them like you are here that I gave you, you don't know all those data values. And so that's kind of why I'm saying outlier with a question mark there, because maybe the least here is 1.3. Maybe there's another value that's 1.4, 1.5. Maybe they kind of all just go along together. We don't really know. If we can imply that, especially with the length of these whiskers and then how close together this box is, it's pretty obvious. But we don't know every data value in the data set, so we can't be positive. What is a typical amount of precipitation? So typical, I mean, we're kind of talking about that measure of center. We still have those here. We don't have the mean, and so we do have the median though. So we could say 1.8, but I want to put a question mark here, right? Because we might have outliers. The data is pretty spread. We don't really know. At the same time, if we do have outliers, maybe the median's the best measure of center here, but it's kind of hard to say a typical data value from a box plot that at least looks like this, like the one in purple. Whereas the one in June, I would say with a lot of certainty that 2.1 would be typical because the box plot is so close together, because we know that June does not have a large distribution of data, aka it ain't spread out. It is not very spread out, whereas January is. So I hope those inferences all make sense. Again, they are just inferences, so just because I'm saying them doesn't necessarily mean that it is the end-all be-all of what can be interpreted from those box plots. But the main thing we do want to pay attention to is that 25% bottom, 25% at the top, 50% in the middle, noticing that interquartile range and things like that. And then again, just making sure that you're following our steps here with our dots and our 3 vertical and 2 horizontal lines to make your box. and your whiskers. So thanks for watching. As always, if you have any questions, please, please, please reach out to me. You can text me on that number on the document. You can message me or chat with me in Teams. You can message me on Remind if you have the availability. You can email me if you need a private video conference. Maybe you don't want to join the Zoom one, you just want one-on-one. Email me. We can do that in Teams. It doesn't have to be through Zoom. We can set that up. If Wednesday's the day that works best for you to set that up, let's do it, because I am here for you guys. And I know that these box plots can be a little difficult sometimes. So feel free to watch this video as many times as you need. Get my YouTube views up, trying to go pro. I'm just kidding. Okay, I'm going to shut up now. Have a great day, you guys.